Good evening, welcome to Maths EAPCET crash course. So we have started off with the chapter of what? Matrices and determinants. In the previous classes we have concluded with matrices and we have started with determinants. So let us continue with determinants. So in the last class we studied what? Idempotent matrix, nilpotent matrix, involuntary matrix, adjoint of a matrix and inverse of a matrix. How to find inverse of a matrix, adjoint of a matrix in the shortcut method, and also properties related to adjoint of a matrix and also inverse of a matrix. Then determinants, okay, elementary transformations related to determinants, all these things we learned, correct na? Now before we go to algebra of determinants, okay, standard determinants I already gave examples. Now let us go to algebra of determinants. There we have actually, when it comes to algebra of determinants, we have what? That is, we are having multiplication, division as well, but in the exam they are asking only sum and difference of determinants. Okay, so instead of going through some what examples, what is that? Instead of giving you some formula here, let us go through some examples so that you understand better. So let us take up an example to understand what do you mean by addition of determinants and also subtraction of determinants. Okay, so let us take up some examples so that you will understand better. I hope I have given what is that? Important determinants, standard determinants in the last class. Have I? If I talk about example here, see here, let us take up a determinant, that is 1, 2, 3, a matrix 4, 1, 4, 5, 3, 2, then plus I will take 7 minus 4, 6, 4, 1, 4, 5, 3, 2, 4, 1, 4, 5, 3, 2. Okay, if we see this matrix, see if we see these matrices, see here, two matrices, their determinants we have to add. The determinants we have to add. So what we can do, one way is to do what? You can find the determinant of this and you can find the determinant of this, you can add and you can get the answer. Otherwise what you can do, directly you can add these matrices and then you can get the determinants. How to add these matrices? See, the consecutive elements are corresponding elements, you will add it, but here observe very carefully, the second row and also third row are same in both the matrices. In what you get the result, there also it should be the same, you won't add it, it will not become 4 plus 4, it will not become 8. So please keep this in mind. So this will become what? 4, 1, 4, okay, here it will be what? 5, 3, 2 only, it will not change. So whatever is same, same thing will be retained here. Same thing will be retained here. This is very important thing you have to remember. Okay, understanding Sahiti, Neha, Anusha, Gayatri, Sharan, Harsha, Sirisha, Shravani, Shravanti, understanding. Vaishnavi, Spandana, understanding. Bhavani, Akshaya, getting it. Siri. So whatever is same, write the same thing. Remaining things what you should do? 1 plus 7 is what? 8. Okay. 2 minus 4 is what? Minus 2. Okay. 3 plus 6 is what? 9. Like this you have to do it, like this you have to do it. Whatever is same, keep it as it is. Whatever is same, keep it as it is. So remaining things you add it correspondingly. Okay, got it? Please write down this example for your reference. Second example I give 1, 2, 3, 2, 1, 0, minus 1, 2, plus 0, 2, minus 1, 0, minus 1, 2, 2, 1, 1, 2, 1, 1, yes, okay, so 2, 1, 1, 2, 1, 1, so this is what is given. Now see here if you observe, what is happening, here if you observe, see these two rows here, this row and this row are same, this row and this row are same, but they are not correspondingly same. Here second row is not same as second row here, third row is not same as third row here, but this first row and first row are different, that is okay. But one thing you have to know here is, see here, I will take one more example. See here, there is a matrix like this, 1, 2, 3, 3, 4, 4, okay, this is what? 2, 3, 2, I will write it, 2, 3, 2, I will write it. So this is the determinant, this is the matrix I have written, determinant matrix, determinant of this matrix. Now what I will do, if I change this row, exchange this row, this R3 will go to R2, R2 will come to R3, once it happens, see R3 R2 if it becomes, you have to multiply with the minus sign outside. So once you do it, you will multiply with 1 minus. So 1, 2, 3. This will become what? 2, 3, 2. What is happening? Third row is going to second row, and second row is coming to third row. What will this be? 3, 4, 4. Once I do that, what will happen? I have to multiply with a minus sign. I have to multiply with a minus sign. Now, if I want to send R2, this R2, if I want to send to R1, R1 if I want to bring it here, what I will do? R2, R1, I will write it like this. So what will happen? This will go up and this will come down. So this will become what? 1. So this will become what? 2, 3, 2, 1, 2, 3, 3, 4, 4. Already minus sign is there. Again you have to multiply with minus sign. So minus whole square, minus into minus, this will become plus. Okay, this is the thing we can do. Same thing can we apply here. We are having 2, 1, 1, 0, minus 1, 2. So for this I can apply it. Okay, what I can do? This one I can send up and this I can bring it down. R3 will become R2, R2 will become R3. So this plus will become what? Minus. Okay, so this will become what? 2, 1, 1, 0, minus 1, 2. So this will become what? Plus will become minus. So whatever the answer we get, in that whatever the two rows that are same, write it as it is, even if it is minus. This will be 2, 1, 1, this will be 0, minus 1, 2. So what about this? Instead of adding, what you should do? Subtract. 1 minus 0 is what? 1. Okay, 1 minus 0 is what? 1. Let me write it here. 1 minus 0 is 1. Now 2 minus 2 is what? 0. Okay, 3 minus of minus 1 plus 1, that is 4. Understood how to do algebra of matrices? Sum and difference, this is how you have to find out. If two rows are same, write the same value as it is. Okay, copy the same thing as it is, then you proceed. Write down this example. This is algebra of determinants, not matrices. What RBS, sir, please slow down, you are going too fast. Okay, let me slow down, fine. Why are you following sir since the first class? Are you able to solve questions? So, okay, fine. See, this is something, this is very simple when it comes to addition of matrices or addition of determinants. Those who watched from the what? The concept of matrices, if I have discussed. If you watch this as the first class, you will find it what? Fast. You people are able to understand? Okay. Anyways, I will try to slow down, or if you want, you can watch it in 0.75 or 0.5x speed also. Or you can slow down, pause it down and watch. No problem. But I have to cover things. I know where to slow down and where to fasten up. Okay. Anyways. Now here you have to write down certain formula of determinants. Write down the formula of determinants. Okay. So first thing that comes is determinant of AB can be written as what? Determinant of A into determinant of B. Anyways, I will take your response void RBX. Okay, don't worry. Determinant of A inverse. Determinant of A inverse. Determinant of A inverse can be written as what? 1 by determinant of A. Determinant of A inverse is what? A inverse can be brought down. Okay, 1 by determinant of A. Determinant of A inverse. Next thing, see here. Alpha into A can be written as what? Alpha, you bring it out, alpha to the power of n, determinant of A. Determinant of alpha into A can be written as what? Alpha to the power of n into A, where alpha belongs to real numbers, n can be the order of the matrix. Okay, n can be the order of the matrix. Next, fourth one, observe carefully. So, adjoint of A, determinant of adjoint of A, not just adjoint of A. This is what? I am missing telling it what? Determinant. You have to understand I am talking about determinant. Determinant of adjoint of A is equal to determinant of A to the power of n minus 1. Okay, to the power of n minus 1. To the power of n minus 1. So, where n is what? Order of A. Order of A. N is what? If it is 3 cross 3 matrix, 2 cross 2 matrix, n is what? 3 there, n is 2 there. Okay, depending on the order of the matrix. Here we are discussing about what? Square matrix only. Okay, next thing. If we talk about adjoint of if I talk about adjoint of A, determinant of adjoint of A, determinant of adjoint of A will become what? Determinant of A to the power of n minus 1 square, whole square. 2 times adjoint means n minus 1 whole square. 1 time adjoint means n minus 1 is n minus 1 whole square. Now tell me, if I write adjoint into adjoint of A. This will become what? Determinant A power determinant of A power n minus 1 whole cube. Clear? Understood now? So if they give it, you should be able to answer directly. Next thing, seventh one, please observe. So if they give adjoint of determinant of adjoint of k times A will be equal to what? Will be equal to k power n into n minus 1, okay, into determinant of A power n minus 1. Okay, this is the properties you must definitely remember. You must definitely remember these properties. Okay, so adjoint of k times of A is what? K will come out. So k power n minus 1, it will not be just n minus 1, n into n minus 1. Okay, k is also there. K times n into n minus 1, okay, into determinant of A power n minus 1. So if they give adjoint of 2 times of A, so 2 will come out, 2 to the power of n into n minus 1 into what is that? Determinant of A power n minus 1. N is what? Order of A. N is what? Order of A. Clear? These properties or formulas you have to remember definitely. By remembering this, so many questions you will be able to solve directly. Okay, that's why you have to remember these properties. Clear? Understood? Now we will go to characteristics equation of a determinant. Characteristic equation. Okay, characteristic equation. Then we will study what is that? Rank of a matrix, and then we will see system of linear equation solving using determinant method. Okay, see matrix inversion method, that you will study for 7 marks, where you should do in your board exam. That will not be following. You will study Cramer's rule, and also what is that? Gauss-Jordan method. Gauss-Jordan method also we will understand. Okay, so let us continue. Characteristic equation. Suppose this characteristic equation what I am talking is always for a square matrix I am talking. Okay, so it will be there for a square matrix. A is a square matrix. A is a square matrix. Okay, then its characteristic equation is given by A cube minus trace of A. Okay, trace of A into A square plus what is it? M11 M22 plus M33 into A into A minus det of A into I is equal to 0. Det of I into A into I is equal to 0. So this is the characteristic equation of matrix A. This is the characteristic equation. This you have to remember. A cube minus what? Trace of A into A square. What is that? A cube, it will start with A cube. A cube minus trace of A into A square plus what is that? Minors. M is what? Minor of 1 1, that element. M11, M22, M33, they are what? Diagonal elements. 1 1, 2 2, 3 3, they are what? Diagonal elements. Minors of the diagonal elements, then multiplied by A minus det of A into identity matrix is equal to 0. This is what? Characteristic equation you have to remember. Okay, because this will be useful in solving many questions. They will give the characteristic equation, then they will ask you to find out alpha, beta, gamma, alpha square, beta square, gamma square. How? I will show you now. A cube minus trace of A into what? A square. Okay, plus minors M11, M22, M33 into what is it? A. Okay, so then comes what? Minus det of A into I, that is plus minus like that. Plus minus it is coming. Okay, now let us take a matrix. For example, let us take a matrix and then we will find the characteristic equation for that matrix. Let there be matrix. Let matrix A is equal to what? 1 2 1 0 minus 1 3 1 3 2. Let this be the matrix. Okay, let this be the matrix. Now observe carefully. Let this be the matrix I am telling. Now see here, we have to find what? Characteristic equation. Just put the values. A cube, keep A cube only. Don't have to do A into A3 multiplication 3 times. No, don't do that. So keep it as it is. So characteristic equation will become what? A cube minus trace of A is what? Trace of this is what? So 1 plus minus 1 0, trace of A is 2. 2 times A square, keep it as it is, plus minus M11 is this one. What is this? Minus 1 into 2 minus 2 minus 3 3 is 9. What is that? Minus 11, correct na? This is minus 2 minus 9 is what? Minus 11. This will be minus 11. What about this one? M22, this one. See diagonal element, this one. See this one you should remove. So 1 into 2, see here, this one. See this one means this one, and this one you should remove. So 1 into 2, correct na? Minus 1 into 2 minus 1. So the answer will be 1 plus 1 plus 1. Now this one, if you talk about this one, this and this, you have to take this 1 into 1 minus 1, minus 1. So 1 into 1 minus 1, 0 into this is 0 only. So this will be minus 1. So what I can take? Plus 1 minus 1 I can cancel. So keep it as it is. Next step we will take. A we will write as it is minus det of A. Det of A is what? So this into this one. See this into minus 1 into this is what? Minus 2, minus 9, minus 11. Okay. What is this? Minus 2 into what is this? Minus 2 into, see 0 into 2. This is what? See minus 2 into 0 into 2 is 0 minus 3. Correct na? Minus 3. The that I can write it as what? Plus 6. Plus 6. Plus 6 I can write it. Then this one. If this will be 1 into what is this? 0 into 3 minus 1. What is this? Minus of minus 1 is what? Plus 1. So this will be plus 1. Correct na? This will be plus 1. This will be plus 1. So what is the determinant of this? Minus 11 plus 7. Plus 7 is what? Minus 4. So this will be equal to what? Minus 4 times identity matrix is equal to 0. So I can write this as what? What is it? Minus 4. Okay, minus 4 means this will become plus 4. So this will become a cube minus 2a square. This is what? What is the value of this? Minus 11a plus 4 times a is equal to 0. This is the characteristic equation of the given matrix. Very simple. If you know this, just put the value. Simple calculation. Basics, multiplication, addition. That's all is there. Okay, but you should be careful. In simple things only we will do wrong. Okay. So a cube minus trace of a into a square plus m11. Diagonal elements minor. m11, m22, m plus m33 into a minus determinant of a into I, that is equal to 0. Okay, clear? Now how the questions will come from this? If you take this up. Now if you see this, they will give, they have given this is the matrix you consider. This itself is a matrix, this itself is a matrix. Okay, for this matrix, if a cube plus alpha a square plus beta a plus gamma into identity matrix is equal to 0, they will ask us to find, then find what is that? Alpha square plus beta square plus gamma square, they will ask you to find. Okay, they will ask you to find this value. They will ask you to find this value. Now, if they have given it in this type, that is the meaning you have to find what? Characteristics equation. Find the characteristic equation and compare with this one. Now this itself, for this matrix, this itself is a characteristic equation. So from this if you compare, alpha is equal to what? Alpha is equal to what? If you compare this and this, alpha is equal to minus 2, beta is equal to minus 11, gamma is equal to 4. So this if you square this, so minus 2 square is what? 4, 11 square is 121 plus gamma square is 16. So that will become what? That will give us 141. So the answer is what? 141 here. So the answer is 141. So like this they will ask the question. So that time what you should do? From this matrix find the characteristic equation, you will get the coefficients. Coefficients of a cube, a square, a and I. That will be what? Alpha, beta, gamma. That will be alpha, beta, gamma for you. Okay. So this is how the questions will come. This is how it will be useful. Now sometimes they will ask A inverse also. A inverse also. See, they will say that if A inverse for the given matrix, for the same matrix I am telling. Okay, I am not writing the matrix again. If A inverse is equal to alpha A square plus beta A plus gamma I, then alpha square plus beta square plus gamma square is equal to what? Is the question. Is equal to what? Is the question. This is the question. What you will do now? So see here, multiply with what? Multiply with A. See, first of all see here, what they have given us for the given matrix. If A inverse is given, If A inverse is given like this, then they are asking us to find what? Alpha square, beta square, gamma square. So in the characteristic equation we are having A cube, but here A square is there. So first of all, any question is given, find the characteristic equation. For the given matrix, for this matrix, what is the characteristic equation? This one only. Write down that first. What is that? A cube minus 2A square minus 11A plus 4I is equal to 0. Now for both LHS, RHS, multiply with A inverse. Multiply with what? A inverse. A inverse into A cube is what? A square. Because one A will come down. This will become what? A square. Okay. What is this? Minus 2A square into A inverse is what? 2A. Minus 11 into A into A inverse is what? A into A inverse is what? I. Okay. A into A inverse is what? Correct na? I. Plus A inverse into I is what? A inverse into I is what? A inverse into identity matrix is what? Think correctly and tell me. These are basic IP concepts you must know. A inverse into I is A inverse only. Correct na? A inverse into I is what? A inverse only, not A. See, I is what? Identity matrix. 1 into something is what? That something value. 2 into 1 is what? 2. 3 into 1 is what? 3. A inverse into 1 is what? A inverse only. So, see, A into A inverse is what? See, 1 by 2 and 2. 1 by 2 and 2 will cancel and you will get what? 1. That 1 is what? Identity matrix. So, A into A inverse is what? I. That is why it is 1. So, 1 into A inverse is what? A inverse only. Like that you take. Okay, understood or not? Akshaya, Bhavani, understood or not? Anusha. So, A inverse into A means what? A inverse into A means it is nothing but A into 1 by A. It will cancel, you will get 1. 1 is nothing but what? Identity matrix. So, A inverse into I is what? A inverse into I is nothing but A inverse into 1. So, that is nothing but what? A inverse only. So, this will become what? 4 times A inverse is equal to 0. Here what they have given us in the question? In the question, if A inverse is equal to, they have given. What they have given us? If A inverse is equal to, they have given. So, why I should take what? I should keep only 4 A inverse, 4 times A inverse in the LHS. Remaining everything I should send to RHS. So, this will become what? Because I want A inverse value. They have given equation is what? This is the question. If A inverse is equal to alpha A square beta A gamma into A, then alpha square beta square gamma square they are asking. So, I have to find the equation in terms of what? A inverse is equal to what? So, this will become what? So, further I can write this as what? 4 times A inverse. This everything if it goes that side, minus A square plus 2A plus 11I is equal to this is what we are having. So, A inverse will be equal to what? Minus 1 by 4 A square. This will be 2 by 4 means I can write it as 1 by 2 A plus 11 by 4 I. Now, what is gamma? What is alpha is? Minus 1 by 4. Beta is 1 by 2. Gamma is 11 by 4. So, alpha square plus beta square plus gamma square, what we should do? So, if you have to find alpha square, beta square, gamma square, alpha square plus beta square plus gamma square, correct na? So, alpha square is what? Minus 1 by 4 whole square, 1 by 16 plus 1 by 4 plus 1 by 16. So, LCM will be what? 16, correct na? So, 1 plus 4 plus 121. So, that will be what? 126 by 16, that is what? Further can we do? Yes, 63 by 8, that is all, 63 by 8. Any answer, that is okay. It is not about finding this, you have to find alpha, beta, gamma. For that, first thing is what? Whenever they give such question, whether it is A inverse or any equation in A cube or something they give, first find characteristic equation of that matrix and then compare. If they give A inverse, what you should do? Multiply the entire equation by what? A inverse. A cube will become what? A square will become what? A will become what? I, and A inverse will become what? I will become what? A inverse. That is all, clear? So, this is very simple question you will get, but you should know how to find what is that characteristic equation. Characteristic equation you have to remember today. Okay, tomorrow if I ask also you should tell what is it? A cube minus trace of A into A square, okay, plus minus. Next is what? Plus, what is it? Minus M11 plus M22 plus M33 into A minus A into plus A into det of A into what is this A plus det of A into I, correct na, minus det of A into I, okay, minus det of A into I, clear. Let us go to the next thing, system of linear equation. Okay, system of linear equation, how to solve this. Before going to Kramer's rule, system of linear equation, we will take up an example and we will solve, no need to take anything else. I am going fast, you able to understand? Okay. Let us take Kramer's rule. Instead of Kramer's rule, first we will take up the question. So, first of all, let us take the example. If it is given a1x plus b1y plus c1z is equal to, what is it? Let us take it like this. Given as d1, a2x plus b2y plus c2z is equal to what? d2. If they are given three equations, system of linear equation, a3x plus b3y plus c3z is equal to, what is it? d3, it is given. Okay, here we will get three matrices, one is in terms of ABC, another in terms of XYZ, another in terms of D1, D2, D3. Okay, so what is this we are having? We will get three matrices. What is that? A1, B1, C1. These questions we have solved already in boards. B2, C2, A3, B3, C3 into, this is what? Into XYZ. XYZ, correct na? Is equal to what? Is equal to this matrix D1, D2, D3. So, if you consider this as A, this entire matrix as, let this be XYZ, this entire matrix as what? This entire matrix as X. So, this will be what? Is equal to what? Is equal to D we will consider. Is equal to D we will consider. Okay, now what we have to do? Now, what we have to do, tell me. How to solve this equation? How we have to solve, you tell me. How we have to solve this now? What does the Kramer's rule say? What type of solutions we will get? What are the various types of solutions we can get? System of linear equations, forgot. What are the types of solutions we can get? All of you I am asking. Same dress girls, tell me. So, one is unique solution, another one is no solution, another one is infinitely many solution. Repeat, what are the solutions? Unique solution. Correct now? That's it. Okay. Now, what we will do is, see, in some books you may see there are finite solutions, there are no finite solutions. Finite, there is infinite solution, another one is unique solution. Finite means limited number of solutions, but there are only unique solution. There is only one solution or infinitely many solution or no solution. Unique solution means there is one and only solution. Okay. So, solutions what we will get? See here, what is it? Unique solution. On solving this you will get unique solution, or you may get infinite solutions, or you may get what? Or you may get, what is it? No solution. No solution. In the question they will not say unique or infinite, they will say consistent. System of linear equations are consistent. Consistent means it can have unique solution or infinite solution. The equation which is having a solution, whether it is unique or infinite, we call that as what? Consistent. But if it is having no solution, we call it as inconsistent. Inconsistent. So, when you see a question, when they are mentioning consistent, this is a consistent linear equation, means it has what? Unique solution, or it may have infinitely many solution. Okay, but if they say inconsistent, it will never have any solution, that is inconsistent. When one solution is there, whether it is unique or infinite, it is called as consistent equations, consistent system of linear equations. Clear? Okay. Now, let us go to Kramer's rule. So, where we will find the delta. Delta is nothing but what? Det of A. Determinant of what we are finding, determinant, that itself is delta. Do not get confused with area of triangle. Okay, properties of triangle. Properties of triangle, delta is what? Area. Okay, here it is what? Delta is what? Delta is nothing but det of A. Let us take some other color. It is coming blur. Okay, now it is fine. Delta is equal to det of A. Delta is equal to det of A. Now, there are various possibilities. If delta is given, if delta is equal to 0, what will happen? If delta is not equal to 0, what will happen? Okay, but before that, what is delta you must know. But before that, what is delta you must know. So see here, observe this again. What is this? A is what? A1, B1, A1, A2, A3, B1, B2, B3, C1, C2, C3. X is what? X, Y, Z. This is what? D is what? D1, D2, D3. Now, what is this delta? Delta means you are finding the determinant of what? Matrix A. That is what? You will write it as what? A1, B1, C1. A2, B2, C2. You can write this down. A3, B3, C3. This is delta. Now, I will say there is something called delta 1, delta 2, delta 3. What is this delta 1? Delta 1 means you will write the same thing, but instead of column 1, I am talking about what? Column. Column 1, you will write what? In place of column 1, you will write not X, D1, D2, D3, you will write it. You will write D2, D1, D2, D3. That is grammar. So, you will write what? D1, D2, D3. This is delta 1. Other elements same. B1, C1, B2, C2, B3, C3. Now, delta 2, very simple. Second column you will write what? See, A1, what is this? A2, A3. They will not come now, you can leave. C1, C2, C3. This will be what? D1, D2, D3. Now, what about this? A1, A2, A3, B1, B2, B3. Okay, this is what? This is delta 3. Now, understood how to find delta, delta 1, delta 2, delta 3? Understood? Now, if delta is equal to 0 or if delta is not equal to 0, if delta is not equal to 0, then what we say? The system of equation. Then the system has what? How many solutions? System has unique solution. The system has unique solution. What do we say? The system has unique solution. When delta should not be equal to 0, then the system has unique solution. Then what is that solution? If you ask me, you said unique solution, what is that solution? Solution is, I can write it as X, Y, Z. Ordered pair, I can write it as what? Delta by delta 1, okay, delta by delta 2, delta by delta 3. Okay, what is the value of X? Value of X is delta by delta 1. Y is what? Delta by delta 2. Z is what? Delta by delta 3. Now, what will happen when delta is equal to 0? When delta is equal to 0, what will happen? When delta is equal to 0, what will happen? See, there can be two situations here also. Here you will get infinitely many solutions and one is no solution. When delta is equal to 0, okay, here there are two possibilities. Okay, delta is equal to 0 and also delta 1 is equal to 0, delta 2 is equal to 0, delta 3 is equal to 0. See, all the deltas are coming equal to 0. Then it has what? Infinitely many solution, infinite solution. He is having what? Infinite solution. First thing is what? Delta should not be equal to 0. If delta is not equal to 0, there is only one solution, that is given by delta 1, delta by delta 2, delta by delta 3. That is what? X, Y, Z. Then you will not consider X, Y, Z, because here if delta is equal to 0, you will have infinitely many solution. You cannot write the value for X, Y, Z. It is having infinitely many solution. If delta is equal to 0, there are two possibilities. First thing is delta is equal to 0. Next thing is what? Delta 1 is equal to 0, delta 2 is equal to 0, delta 3 is equal to 0. All the four deltas are equal to 0 means infinitely many solution. Next thing, delta is equal to 0, but either delta 1 is not equal to 0 or delta 2 is not equal to 0 or delta 3 is not equal to 0. If any of the delta is not equal to 0, then it has no solution. Then it has what? No solution. Understood? Please make a note of it. These are Kramer's rule will help you. Any doubt?
Delta 1 by delta.
What is?
Delta 1 by delta.
Just let me check. That is correct. Just a mistake here. Delta 1 by delta, this is delta 2 by delta 3 by. This will be what? Okay, that's it. Now clear? Understood now? So, yeah, you will get the proper fraction then. Now this will become what? Delta 1 by delta, delta 2 by delta, delta 3 by delta, that is nothing but what? X, Y, Z. Okay, that will be what? Equal to X, Y, Z. So first thing is what? You will find delta, delta 1, delta 2, delta 3. I know, you know how to do it, correct na? Delta, delta 1, delta 2. That is, you have to think about the column, not rows. Please keep this in mind. Then what you will do? You will check whether delta is equal to 0. Once you check delta is not equal to 0, once you check delta is not equal to 0, what you will do? See, here only you can find out. When delta is not equal to 0, then you will check for whether it is unique solution. When delta is not equal to 0, you will find delta 1, delta 2, delta 3, then you will get what? You will get unique solution. Okay. Then if delta is equal to 0, only thing is there is no unique solution. Okay, there is no unique solution, but you have to check whether it is infinite or no solution. You will find delta 1, delta 2, delta 3. If all are coming equal to 0, this is also 0, this is also 0, all the 4 are 0, then it is infinitely many solution. But this is equal to 0, this is equal to 0, this is equal to 0, but this is not equal to 0. Either one of them is also not equal to 0, you will get what? No solution. Okay, or if this is equal to 0, but this one is not equal to 0, this one is not equal to 0, this one is not equal to 0. Any of one is not equal to 0 means no solution. Clear? So, like you told x, y, z how to find? Not delta by delta 1, it is what? Delta 1 by delta, delta 2 by delta, delta 3 by delta. Clear? Understood? Okay. Done all of you? Okay. Now let us go to Gauss-Jordan method. Before that, let us do what is that? Rank of a matrix. We will do what? Rank of a matrix. Rank of a matrix. Suppose let us take a matrix A. We will take a matrix A, that is 1, 2, 3, 4, 5, 6, 7, 8, 9. This is the matrix we have taken. Okay. Now, here rank of a matrix. So, first thing here to find rank of a matrix, if det of A is equal to 0, det of A is equal to 0, that time rank of A, this is what? 3 cross 3. This is what matrix? 3 cross 3 matrix. If det of A is equal to 0, then rank of A will not be equal to 3. Det of A, this matrix is what? This determinant is what? 3 cross 3. For this 3 cross 3 matrix, if determinant is coming equal to 0, rank of A will not be equal to 3. Rank of A will not be equal to 3. What do you mean by otherwise? Otherwise, if det of A is not equal to 0, rank of A will be equal to 3. That a converse, if I say converse, what will happen? Rank of A will be equal to 3. Okay, rank of A will be equal to 3. So, to find rank, there are two methods. To find rank, there are how many methods? Two methods. Okay. Now, see here. Please write down, important. To find rank of A, there are two methods. One is determinant method. Okay, one is what? Determinant method, finding the determinant. Next is elementary transformation. Elementary transformation. Okay, which way? Elementary transformation? Only row wise, no column wise, only row wise. Only, what is this? Only row wise. Elementary transformation, only row wise. So, this is the thing. So, what happens when we talk about det? What happens when we talk about det? Already I told you, if det of A, or I write it like this. If det of A is not equal to 0, then what will happen? Rank of A will be equal to 3. If det of A is not equal to 0, rank of A will be equal to 3 right directly. Okay, directly rank of A is equal to 3. But if det of A is equal to 0, rank of A will not be equal to 3, but it will be less than 3. What is that value? Whether it is 2, 1 or what, we will find out. How to find out, we will tell. So, this is what elementary transformation row wise, I will tell you how to find. So, first thing is what? For a given matrix, find determinant. You find the determinant. If it is not equal to 0, whatever the order, 3 cross 3, 4 cross 4, 5 cross 4, that will be the what? Rank of the matrix. If determinant is equal to 0, then rank of the matrix will not be 3. It will be less than 3. Whether it is 2 or 1, we will find out. How? I will tell you. Now, let us find the determinant of this matrix. For this, you do not have to do the entire determinant. You can find out only with this one. Okay, you can find out this first row, first column. This is what? See here, 1, this first row, first column, leave it. So, what you will do? 5 9s are 45, 8 6 are 48. So you are getting what? Minus 3 is not equal to 0. So what is the rank of A? What is the rank of A? 3. That's it. Okay. Rank of A is what? 3. Yeah, you can go. See, just a minute here. You have done one mistake. Now, this is the thing I have to do in the second step. Actually, okay. Four, 5, 6, 7, 8, 9. If you take this, now find the determinant of this. Find the determinant of the entire A. What you will get? See, 1 into 5 nines are 45, 6 8s are. So this is what? Minus 3. Okay. Next, minus 2 into what is this? Minus 2 into 4 nines are 36, 7 6 are 4 nines are 36, 7 6 are 42. So this will be what? Minus 6. Minus 6 into 2 is what? Plus 12. Minus 6 into minus 12 is minus 2 is plus 12. Now look at this one. 4 8s are 32, 5 7s are 32, 5 7s are 35. 4 8s are 32, 5 7s are 35. This will be what? Minus 3. Correct na? Minus 3 into 3. That is what? Minus 9. 3 into 3 minus 9. So what we will get? Minus 3. This will be minus 12 plus 12. So delta of A is coming equal to 0. This is equal to 0. Delta of A is coming equal to 0. Now what we should do? Then definitely rank of A will not be equal to 3, or you can say less than 3. Now let us check whether the rank of A is equal to 2. So how to do that? You remove first column and first row. First column and first row, if you remove, what you are getting? This one. So you will get what? 5, 6, 8, 9. This is what? This is a 2 cross 2 matrix. Now find the determinant of this. If determinant of this is also coming equal to 0, then directly you can write rank of A is equal to 1. But if it is coming not equal to 0, rank of A is equal to 2. So you have to find till when you will find the determinant? Till you get not equal to 0. Where you are getting not equal to 0, 2 cross 2 means then rank of A is equal to 2. But rank of this also, it is coming equal to 0 means rank of A is equal to 1. Okay, rank of A is equal to 1, you have to take it. So see here, this will become what? Already founded, this will be what? Delta of this will be minus 3, is not equal to 0. So rank of A is equal to what? 2. Rank of A is equal to 2. This is 2 cross 2 matrix, no? See, first we took 3 cross 3 matrix. For that determinant is coming equal to 0. When it is coming equal to 0, rank cannot be equal to 3. Equal to 0. Rank, see, equal to 0. Rank cannot be equal to 3. It should be less than 3. See, first we took what? Those who went out, first we took what? Find the determinant of A. If you find the determinant of A, it is coming equal to 0. So rank of A cannot be equal to 3. It should be less than 3. Now we take 2 cross 2 matrix. How to take? First row, first column you remove. Take the 2 cross 2 matrix. Any 2 cross 2 matrix you can take it, but I am taking this 2 cross 2 matrix. Okay. So for this, if you are getting what? If you are getting not equal to 0, so the rank of A is 2. But if you are getting equal to 0, rank of A will be what? Less than 2, that will be 1. You can take like that. Clear? Now another way is what? Elementary transformation. I told only row wise. So let us do that method now. So we got what? Rank as what? Rank as 2, we got it. Okay. Now let us check in row wise whether we will get 2 or not. We will take the same matrix. See here, we will take the same matrix. What is the matrix that is given? So A is equal to, let us take it as what? 1 2 3 4 5 6 7 8 9. So we have to do the transformation. Please listen. So we have to do the transformation row wise. So let us do what? Let us do R3 is equal to what? R3 is equal to R3 minus R1, R3 minus R2 we will do it. R3 minus R2 will do it, and we can also do what? We can also do R2 is equal to R2 minus R1, R2 minus R1, R2 minus R1. On doing this, what we'll get? We'll get it as what? 1, 2, 3. This will be what? 4 minus 1 is 3, 5 minus 2 is 3, 6 minus 3 is 3. This will be what? This will be 3, 3, and this is what? Okay, so this is what we are getting. So 3, 3, 3, correct na? So further if I do what? R3 minus R2, I'll get what? If I do R3 minus R2, what I'll get? R3 minus R2, if I do 1, 2, 3, this will be 3, 3, 3, this will be what? See, R3 is equal to, I should do what? R3 is R3, if I am starting the formula, R3 should start with R3 only. So this will become what? 0, 0, 0. Okay, now after doing this, okay, further if I do, what I should do? R2 minus R1 can I do? R2 minus R1, R2 is equal to R2 minus R1. Okay, what I'll get? 1, 2, 3, this will be what? 1, what is this? This will be 2, this will be 1, and this will be 0. Okay, this will be 0, 0, 0. How much ever transformation if I do also, I'll get end up with these two rows will remain as it is. These two rows you cannot change further. You cannot make it same, you cannot change further. Only one row is eliminated. Now this is what? 2 rows are remaining. So rank of A is what? Rank of A is what? 2. This is removed means how much rows are remaining as it is. This rank of this is what? This is made 0. How many other rows are remaining? 2 rows. So rank of A will be what? Equal to? Not 0. Rank of A will be equal to 2. Rank of A will be equal to 2. So first find the determinant. Okay, determinant is not equal to 0 means you will get the rank of A is equal to 3. If it is equal to 0 means less than 3, you have to find it. Okay, so find it like this, 2 cross 2 matrix. What you will get? If it is not equal to 0, you will write rank of A is equal to 2, otherwise rank of A is equal to 1, just like that. Okay, clear? Otherwise row wise you should do, row wise transformation. Row wise transformation when you do, how many rows remain unchanged, or how many rows are there except for getting 0, 0, 0. See, how many rows are there which are having some elements except for 0, 0, 0. See, here we are having 0, 0, 0. Okay, these two rows we cannot change further. If you change also, you will never get 0, 0, 0. You cannot get 0, 0, 0. So these two rows will remain unchanged, or you cannot get 0, 0 from here. So these two rows are called as what? Rank of this is what? 2. Class lo unnanu cheppandi. Rank of this is what? 2. Rank of this is what? 2. Now you can do it this way or this way. So further if I do, and if I get this row 2 as 0, 0, 0, only how many rows are left? Only one row. So that time rank will become what? 1. That time rank will become what? 1. Okay, that time rank will become what? 1. Clear? So you can write this down. I'll just be back. What is this? Okay, let us continue. I hope I am audible. Check. Now let us go to Gauss-Jordan method. So what does Gauss-Jordan method says? Here we study something called augmented determinants, that is called AD, augmented determinants. So see here, suppose they have given an equation like this, like how I told a1x plus b1y plus c1z is equal to d1, same thing like previous one, b2y plus c3z is equal to d2, a3x plus b3y plus this should be c2, c3 z is equal to d3 if it is given. Okay, so here we combine and write a and what is that, d. Here we will combine and write a and d, we will not write x. Okay, here we will combine and write what, a and d. How is that? So see here, what is this A matrix? a1, a2, a3, b1, b2, b3, c1, c2, c3. We will give some gap and we will write it as what, d1, d2, d3. We will write this matrix as what, a slash d, or we will write one line here. Okay, this is called augmented matrix. This is called augmented matrix, where we will be using Gauss-Jordan method. Okay, you can follow this method or you can follow Kramer's rule, whatever you want you can follow. Now what does this method say? Okay, what does this method say? So here also what you should use, elementary transformation only. Here also what you should use, elementary transformation only. So Gauss-Jordan method like this they will give, they will ask what, they will ask rank of the matrix. Mainly they will use Gauss-Jordan method to ask you what, rank of the matrix. Okay, now rank of this AD if I ask, rank of this AD, AD means what, augmented matrix, that is you have to understand they are using what, Gauss-Jordan method. Instead of asking rank of A, what they can ask, Ritika, they can ask rank of AD. Okay, you have to wake up. So others also you have to wake up. So this is what, rank of not just A, rank of AD. If they ask, it is nothing but rank of A only they are asking. So that is what, it is 3 here, 3 cross 3. Okay, assuming the determinant is not equal to 0, rank will become what, equal to 3. Okay, so first thing here certain properties are important, please write down. If rank of AD rank of AD is equal to rank of A is equal to 3, that is it is 3 cross 3 matrix, 3 cross 3 matrix if you are taking. Okay, then it has what, then system has what, unique solution, then system has unique solution, system has unique solution. Next, if rank of AD, okay, is equal to rank of A is less than 3, rank of AD is equal to rank of A, but it is less than 3. Okay, it is less than 3, then system has, then it has infinite solution, infinite solution. Next, if rank of AD is not equal to rank of A, is not equal to rank of A, then no solution, then no solution. So here you can use transformation, row wise transformation or row wise transformation only, not column wise here also. So please make a note. So here, see here what is this AD matrix? AD matrix is combining these two matrix. Combining these two matrix, what do we get, rank should be equal to rank of A. Here what is this matrix? This is rank, this is what, A. This combined is what, AD. This entire thing is AD. This is what, A. This matrix is what, A. So if you find rank of this, and this is what, see rank of AD and rank of A. This rank of AD is what, this is 4 cross 4. This is not 4 cross 4, this is you should consider as what, A into D, that's all. Don't worry about, this is not 4 cross 4, this will become 4 into 3 only. You should consider it as square matrix only. So this is what, rank of A and rank of AD you have to compare. If it is coming equal, first thing is what, if it is equal, okay. If it is not equal, directly write no solution. Rank of AD and rank of A is coming equal, okay. So you will get what, if it is coming equal, definitely there can be a solution. One is unique solution, another one is infinitely many solution. If rank of AD, rank of A is coming equal to order of the matrix A, order of the matrix is A is what, 3 cross 3. So that is coming equal to 3, then we will have what, unique solution. If it is coming less than 3, it will have infinitely many solution. Clear, understood, got it? These are the concepts that are there when it comes to determinants. So one is Kramer's rule, another one is what, Gauss-Jordan method. Understood, Bhavani, Anusha, Neha, getting it? Sirisha and Shravani and Shravanti. Vaishnavi, got it? Gayatri and Siri, same dress girls. Okay, now let us do some previous year questions related to this. Look at this, they have given, let A is equal to some matrix. If A inverse is equal to what? Alpha square, alpha into A square plus, this should be, what is it? See, this should be alpha into A square. Let me check the question. Alpha into A inverse is equal to alpha into A cube. See, beta into A square plus gamma into A. This should not be what? Alpha into A square plus beta into, what is this? A plus gamma into I plus gamma into I. Okay, this is what is given. See, you are only able to find out the question also now. See here, alpha into A square, beta into A, gamma into A. So, A inverse is given means A cube won't come, A square will only be there. Okay. So, A square is given like this, there is a mistake in this question, see. So, they are asking alpha, beta, gamma are real numbers and I is a 3 cross 3 matrix, they are only telling. Okay. Then 17 alpha 55 beta plus gamma is equal to what they are asking. So, we have to find what? Alpha, beta, gamma. So, A inverse is given. So, for this we will find what? Characteristic equation. Characteristic equation of 3 cross 3 matrix or any matrix is given by what? This is what? A cube minus trace of A into what is this? A square minus plus, this is what? M1, MM222, M33, A into minus det of A into I is equal to 0, is equal to 0. First we will find out the characteristic equation. A cube minus trace of A is what? 5 into A square minus minor of this one. This is what? Minor of this one is what? 1 into 2, this is what? 2. Okay, I will write here 2. So, this is what? So, this will become what? See here, minor of this is what? Minor of this is 1 into 2. So, this will be 2. Minor of this is what? So, this one and this one you should remove. 2 2s are 4. 4 minus 1 is 3. So, plus 3. Now, minor of this is what? Minor of this is 1 into 0. See, minor of this is what? 2 into 1. 2 into 1 minus 0. So, this is what? Plus 2. Correct now? Plus 2. So, we will get what? 5? 7. Okay. We will get what? 7 times A. 7 times A. What is this? Det of A. Det of A is what? We have to find out. So, det of A, if you take it, see here, 2 into 1 into 2 is what? 2. So, this will become what? 2 into 2 is 4 minus 1 into, this is what? 0 into 2 is 0, 1 into 0 is 0, this will be 0 only. Okay. 1 into this is what? 1 into 0 into 1 is 0 minus 1. So, this is what? 4 minus 1, 3. So, this will be what? What is this? Minus. So, this will be what? Minus 3I is equal to 0. Now, A inverse I will multiply for all of this. So, this will become what? A square minus 5A. Okay. What is this? Plus 7I minus 3 into A inverse is equal to 0. So, A inverse I will send it that side. Okay. So, 3 times A inverse if I send it that side, I will get what? 1 by 3 A square minus 5 by 3 A plus 7 by 3I is equal to what? A inverse. Now, A inverse is given. So, alpha is equal to what? 1 by 3. Okay. Alpha is equal to 1 by 3. They are asking what? 17 alpha, that is what? 17 into 1 by 3 plus what is this? 5 into beta. 5 into? So, I will write it like this, minus 5 into what is this? Minus 5 by 3. Then what is it? Gamma. Gamma is what? 7 by 3. 7 by 3. So, this will be what? 17 into 3. 17 by 3 minus 25 by 3 plus 7 by 3. So, minus 27 minus 24. This is what? Minus 1 by 3. Minus 1 by 3, second one. Very simple. Understood? Little lengthy you have to find, but the answer you will get easy. Correct na? See, 2022 they have asked Telangana. See 1 minus 1 by 3 will get it. First you should know how to find characteristic equation. Once you find it, multiply with A inverse, then you will get like this. So that is why characteristic equation is important for you. You will get one question at least from characteristic equation. Clear? Okay. Any doubt you have? Okay. So look at this. If the set of equation x plus this one, this has a into z plus az. Let me take this. Look the question. So they are telling Az as unique solution. They are telling it is having unique solution. So first of all, let us write the equation. What is that? X plus 2y plus 3z is equal to 6. Okay. X plus 3y plus 52 is equal to 9. 5 52. Okay. 5z. Okay. 5z. So this will be what? 2x plus 5y plus az is equal to b. Okay. Is equal to b. Now let us write down the matrix A. Matrix A, let us write down. So matrix A will get it as what? 1 2 3. Okay. 1 3 5, and then the next is what? 2 5 A. Unique solution they are telling. Unique solution means what? Determinant of A should not be equal to 0. Delta should not be equal to 0. Correct na? This delta should, using Kramer's rule, delta should not be equal to 0. Don't go for delta 1, delta 2, delta 3, not required at all. So delta should not be equal to 0. So that means what? This should not be equal to 0. So once you see unique solution, delta should not be equal to 0, that should come to your mind immediately. So take delta, make it not equal to 0 and find the value of A. So here we can find the value of A. So this will be what? Find delta of A. So delta of this capital A, that is matrix A. So what you will get? 1 into this is what? 3 into A minus 25, minus 25. So 3A minus 25. Next, what is this? Minus 2. Minus 2 into what is this? 1A minus A minus 10. Correct now? So this I can write it as what? Minus 2 into what is this? A minus 10. A minus 10. Correct. Next we are having what? 3 into what is this? 5 minus 6 is not equal to 0. So this will be what? 3A minus 25 minus 2A plus 20. Okay. What is this? Minus 3. This will be minus 3 is not equal to 0. So 3A minus 2A is what? A. Minus 25 plus 20 is what? Minus 5. Minus 8 is not equal to 0. So A is not equal to 0. A is not equal to 8. So what is the option? A is not equal to 8. Option B. That's all. Very simple. See, such simple questions are coming. But you should know the concept. Once you see unique solution, delta should not be equal to 0. Put the value, find the value of A. Clear? That is how you got to solve it. Clear? Understood? Okay. If they give infinitely many solutions, what you will do? Delta is equal to 0, delta 1, delta 2, delta 3, all will be equal to 0. Based on the condition, you will solve the question. Now, look at this question. So the system of linear equations, this one is given, has infinite number of solutions, finite number of solutions. There is no finite number of solution. Remove this. Okay. Suppose in the end you are taking the answer, you don't have time. Finite number of solution, there is nothing called finite number of solution. So you have to remove this. To confuse you, they will give. There will be infinite or solutions. Infinite solution, unique solution or no solution. So out of these three only you should go. So first let us check this. What is it? It is given as what? X plus 2y plus z is equal to minus 3. So for this let us take the matrix. Matrix A, that is what? 1 2 1. Okay. Then what is it? 3 3 minus 1 minus 2. Okay. Next is what? 2 7 7. So let us find delta of this. Okay, delta of this let us find out whether it is equal to 0, not equal to 0. So delta of this is not equal to 0 means you will get directly unique solution. So let us find this. This will become what? 3 7s are 21. 3 7s are 21 plus 7 2s are 14. 21 plus 14 is what? 35. This is minus into minus plus 7 2s are 14 plus 21 is what? 35. Next minus 2 into what is this? 3 7s are 21 plus 4 plus what is this? 1 into what I can write? 3 7s are 21, no? 3 7s are 21 minus 6 is what? 15. Correct or not? So this will be 15. Please focus. 35 minus 21 plus 4 is what? 25. 25 into 2 is minus 50 plus 15. So we are getting 50 minus 50, that is equal to 0. We are getting equal to 0. Now we will find one of the debt. Okay, we can get what? Definitely what? Unique solution is removed. Now check whether it is no solution or infinite number of solution. What is the answer? Try this. For this what we will do? Just find another one delta 1. If it is coming equal to 0, then you have to find delta 2, delta 3 also. If delta 1 is coming not equal to 0, if delta is equal to 0, delta 1 is not equal to 0, what is the answer? No solution. No solution. Okay. So let us find delta 1. So delta 1 means what I should do here? What I should do instead of this first column, what I should write? What is this? Minus 3, minus 3, minus 1, minus 4. So this will become what? 2, 3, 7, 1, minus 2, 7. Okay. So delta 1 will be equal to what? Find the value. So minus 3 into what is this? 3 7s are 21 plus 14, that will be what? 35. Okay, 35 minus 2 into what is this? Minus 2 into minus 7, minus 7 minus 8 is what? Minus 7 minus 8 is minus 15, correct na? Minus 7, this will be what? Minus 15. I can write it as what? Plus 30. Directly I'll write what? Plus 30. Next 1 into this is what? Minus 7, what is this? Plus 12. Minus 7 plus 12 is what? Plus 5. Correct na? Plus 5. So this, by looking at it only, you can say minus 3 into 35, this is not equal to 0. This is not equal to 0. The answer is what? No solution. If you want, you can find out. 35 into 3 is what? 35 into 3 is 105. 105 minus 35 is what? It's minus 70. Here we will get what? Minus 70 is not equal to 0. So delta is equal to 0. Delta 1 is not equal to 0. Is this what? No solution. Clear? Understood everyone? Got it? Clear? Next question. Easy, no? Questions are easy if you know the concept. Just by the concept we are able to do. Look at this Gauss-Jordan method. Ax is equal to d represents the system of linear equations. Okay, it is given like this. Rank of A is equal to rank of AD is equal to what? Like that they have given. Okay, so like this they have given. Now what we should do? So we have to find rank of AD or rank of A. Okay, let us find out. Now what is it given? Ax is equal to d. So 3x minus 4 plus 7z plus 6 is equal to 0. 5x plus 2y minus 4z. So well, first let us write down the matrix A. That will be what? 3 4 7. Next is what? 3 minus 4. This is what? 5 2 minus 4. Next is what? 8 minus 6 minus 1. Find the determinant of this. Otherwise you are just sitting and watching. Find the determinant. I am solving, you people are just seeing. What you will get? Is it equal to 0 or not equal to 0? Not equal to 0 means what? Rank of A will be equal to what? 3 cross 3 matrix means rank of A will be equal to 3. So that will be equal to rank of AD. Rank of A is equal to 3, that is rank of A is equal to rank of AD is equal to 3, only option 3. That's all. Understood? Any doubt? So once it not equal to 0, rank of A will be equal to the order of the matrix 3. Once it is equal to 0, you have to eliminate first row and first column. Go for check for rank of 2. So here rank of A is equal to rank of AD is equal to 3. Okay, don't have to check for rank of AD at all. So only one option is there, that is having rank of 3. So that is third option. Clear? Understood everyone? Who else is there? Purnima madam. Okay, fine. Please take up this question, all of you. You have to do it by yourself. Take up this question, do it by yourself. You can take up the question, you can do it later. I will be checking tomorrow. I may ask one of you to come and do. So this is the question. They have given A, det of A square is 25 they have given. Then A is equal to what? So first you will find what A square, then you will find what det of that. Correct, no? Then you will get the value of A. So fine, then we will wind up. So when it comes to determinant, matrices and determinants, we have covered all the concepts that is required for your exam. Okay, we have solved some or more PYQs we have done. Lot of questions of matrices and determinants also we have done. We will be doing some more questions in the study hour, in the upcoming study hours also. And also in tomorrow's class we will be starting with what new topic, that is binomial theorem. Clear? I will wind up now. Thank you.